We have already learned what are kinematic equations and how to use kinematic equations to find out unknown quantity related to moving object, which shows uniform acceleration. So, the kinematic equations are V is equal to U plus AT, S is equal to UT plus half AT square, V square equal to U square plus 2AS. Today we will learn how to derive or how to write down proofs for these kinematic equations. What do you mean by to derive or to write down proof for any equation or for any formula? To derive a formula or equation means to deduce or to prove that formula from a set of already known or already established principles or facts. So, today we will prove kinematic equations. You might have written proofs earlier in geometry, but I guess this is your first time you are writing proof in science. So, first we will derive first kinematic equation. For that, we have to consider one example or one situation. So, let us see what that situation is. Let us consider an object moves from point A to point B. When object is at point A, it is moving with some velocity which is non-zero, that is u. And when object reaches at point B, it gains the velocity v. And this change in velocity takes place in time t. Let us express this situation in motion graph. Already you have studied motion graphs, right? So we will derive these kinematic equations with the help of motion graphs. Here in the situation, they are talking about change in velocity of moving object in time t. So here the graph of velocity against time is drawn. So what we were talking about, which situation we have considered? An object moves from point A to point B. When object is at point A, it is already in the state of motion. Already it is moving with some velocity, that is u. When object reaches point B, its velocity becomes v and the time required for the same is t. So to enclose that time period or to find out that time period, let us draw perpendicular from point B and A on x-axis. So let us draw perpendicular from B on x-axis. Let us label the point which meets where perpendicular from point B meets x-axis, that is C. Let us label the point at which perpendicular from A meets x-axis, that is D. So, what is the time in which this change in velocity has been taken place? That time duration is t. Now, for the sake of derivation or proof, we are going to do one construction. We are going to draw one perpendicular from point A to segment BC, and the point at which this perpendicular meets segment BC will be labeled as, say, E. This construction is done to make our things easier when we will start deriving the equations. So with this graph, let us derive first kinematical equation, that is V is equal to U plus AT. For this, we will use the diagram which we have developed earlier. So here we are supposed to find out V is equal to something. That means we will find out value of V. So if you look at the diagram, which segment corresponds to V? Here if you see, segment BC is equivalent to V. So if you want to find out value of V, let us find out value of segment BC. If you see here, this BC is made up of BE and EC. Let us write down that BC is equal to BE plus EC. Now let us substitute the values. All of you know, just now I have told you BC is equal to what? V. BC is equal to V. So let us write down V for BC. Even look at EC. EC is equal to what? EC is equal to U. So let us write down EC is equal to U. And for the time being, let us write down BE as it is. Why I have done so? Why I have written BE as it is? Just have a look at the diagram. This BE is equivalent to what? Change in velocity. Final velocity minus initial velocity it shows, right? So BE is equal to V minus U. So if we put B is equal to V minus U, let us see what happens. So V is equal to V minus U plus U, and we will end up getting V is equal to V because plus U minus U will get cancelled out, and this is not what we are looking for. We are looking for the first kinematic equation, that is V is equal to U plus AT. So what can be done now? Instead of substituting VE is equal to V minus U, we will put something else. Now something else means something which is equivalent to V minus U. Now what can be done for the same? Now this motion or the motion exhibited by this object is accelerated one, isn't it? Because clearly it shows change in velocity in given time. So its motion is accelerated. So let us find out its acceleration. Acceleration is equal to change in velocity upon time. So what is change in velocity? V minus U time t. So now if you look at the diagram, see what U minus V minus U is. V minus U is nothing but BE, isn't it? So let us substitute V minus U as BE, and you will get then BE is equal to 80. And now let us come to our previous equation. Here we have got V is equal to BE plus U. So instead of putting VE as 80, we will get V is equal to 80 plus U. This is our first kinematic equation. Now let us derive second kinematic equation. What is second kinematic equation? S is equal to ut plus half at square. So here we are supposed to find out value of S. What is S here? S is nothing but displacement. All of you have studied this before. When velocity time graph is given, how to find out displacement? Displacement then is nothing but area under the curve. Here which is the curve? Curve is AB, and area under the curve is nothing but displacement. So if you find out area of this quadrilateral ABCD, you will get the value of displacement. So if you observe this quadrilateral ABCD, that quadrilateral ABCD is made up of two geometrical figures, right? One is right angle triangle BEA and another is rectangle AECD, isn't it? So let us write down that we will get displacement if we will find out area of triangle BEA and area of rectangle AECD, and if we add them together. So let us first focus on area of right angle triangle BEA. So what is the formula to find out area of right angle triangle? It is half base into height. So what is base here? Base is AE and height is BE, isn't it? Okay, so how to find out area of rectangle? What is the formula for the same? Length into breadth. So what is length here? Length is AE, or you can take DC, and breadth is you can take CE or AD, isn't it? So let us write down that here. Now we will substitute these values of segments. So AE corresponds what? Where is AE? First find out AE. AE corresponds to DC. And for AE or DC, what can we write down? T. Right. BE. Look at B. Where is BE? Here I can see BE. Do you remember while deriving first kinematic equation, we had calculated value for BE. What was that? 80. So instead of BE, we will write down, instead of writing V minus U, as 80. Then AE is what? AE. Where is AE? AE is nothing but DC, and that is nothing but T. Where is AD now? AD is equivalent to U. So for AD, you can write down U. Let us substitute these values. So after substituting these values, and if you rearrange these terms, you will get S is equal to UT plus half AT square, and that is second kinematic equation. Okay. So here you might be wondering why we have substituted AT for BE. Why we haven't directly substituted BE? Now if you look at BE, you will find BE is nothing but V minus U, right? But in our equation, is there anywhere V and U? No. And we are supposed to prove which kinematic equation? Second kinematic equation. And in second kinematic equation, you don't see V and U, right? So we will put something which is equivalent to V minus U. And in earlier, we have already calculated BE is equal to V minus U, and that is equal to 80. Fine. So we have derived second kinematical equation too. Now let us derive third kinematic equation. Do you remember what is third kinematic equation? It is V square equal to U square plus 2AS. So here also unknown quantity is S. So S is equal to what? S is equal to displacement. So let us first write down that S is nothing but displacement. So if we find out the value of S, ultimately we will end up getting third kinematic equation. Let us see how. So here also, to find out displacement, we will consider area under the curve AB, since it is velocity time graph. So area under the curve AB means we will find out area of quadrilateral ABCD, isn't it? So to get value of S, we will find out area of quadrilateral ABCD. Now you will say we have done that earlier, right? We have done that earlier. But now we will use some different technique for the same. Otherwise, we will end up getting second kinematic equation. So we will employ different strategy to find out area of quadrilateral ABCD. So if you look at area or if you look at quadrilateral ABCD, what type of quadrilateral it is? It is trapezium. So we will use the formula to find out area of trapezium ABCD. Do you remember what is the formula to find out area of trapezium? Yes, you are right. It is nothing but half into addition of two parallel sides multiplied by height, right? So here which two parallel sides are there? BC and AD, right? And what is height? Height is either you can write down AE or you can write down DC. So let us write down these segments. Now let us write down the values for these segments. Let us see what are the values for these segments. BC. Look at the segment BC. BC corresponds to what? BC represents V. So for BC we can write down V. Then AD. AD corresponds to what? U. isn't it? AD is nothing but U. Then AE. AE is equivalent to DC, which is equivalent to T, isn't it? So let us substitute these values. Now, if you recollect that third kinematic equation, V square equal to U square plus 2AS, you will not find anywhere this T, right? Okay, so we don't want that T here. So what can be done? Can we simply erase that T? No. We are supposed to write down something which is equivalent to T. So what is that something which is equivalent to T? Let us find out. Here also we are going to use the same formula of acceleration. Acceleration is nothing but v minus u upon t, and if you rearrange the terms involved, that means let us take t to left hand side, that means at is equal to v minus u, and then you will get t is equal to v minus u upon a. So this value of t we will substitute here. So let us put this value of t as v minus u upon a here in place of this t. Now let us rearrange the terms further. Now you will come across something which is familiar to you. What is this v plus u, v minus u? Yes, it sounds like a plus b and a minus b, right? A plus b multiplied by a minus b. So it is a famous algebraic identity. So what will you write down? Instead of v plus u and v minus u, you can write down v square minus u square, right? So just by now rearranging the terms, you will get the desired third kinematic equation, that is 2as is equal to v square minus u square, or v square is equal to u square plus 2as. Now you have learned how to write down derivation in physics for the first time. Listen this once again and then try to write down on your own. In just one go, you may find out this little difficult, but hear it twice, thrice, and surely you will understand this. There is nothing difficult in it. And when you will start writing down, you are supposed to write down first situation. Based on that situation, you have to develop one graph as I have developed, and then do the calculation part. Okay?